Okay, Assalamualaikum warahmatullahi wabarakatuh. Sekarang hari ni kita sambung lecture kita untuk lecture 7 and lecture 8. Okay, starting from today, semua yang kita cover ni akan disoal dalam quiz 2, assignment 2 dan final exam. Okay, so sekarang for lecture 7 and lecture 8, induction and recursion. Okay, lecture content for this lecture will be mathematical induction, recursive function, recursive definition, and defining recursive definition. Okay, first, mathematical induction. Many mathematical statement assert that a property is true for all positive integer. Okay, selalu kita tengok kan dekat dalam ayat-ayat, macam contohnya ayat ni, n factorial is less or equal to n power of n. Then the sum of first n positive integer is n plus 1 divided by 2. Okay, now before we introduce such example mathematical statement like this, we have to prove whether it is true or not. Okay, how can we prove? By using mathematical induction, which can be used to prove tremendous variety of results. Mathematical induction is based on rule of inference that tell us that P1 and for all Pk plus 1 are also true. Okay, so for mathematical induction, the important thing is we have to prove that initial point, which is initial point here is basis function is P1. Then we have to prove another thing is Pk become Pk plus 1 is also true for domain positive integer. Then for all Pn is true. First, they show that statement hold for positive integer 1 called basis step. Okay, this one we call it as basis step. Second, they show that if the statement hold for positive integer, then it must also hold for the next larger integer called inductive step. Meaning that after the initial step is true, then for next number for Pk and Pk plus 1 will become true. Okay, this is the inductive step. Okay, understanding how to read and construct proof by mathematical induction is a key goal of learning discrete mathematics. Okay, this is the principle of mathematical induction. First, to prove that Pn is true for all positive integer n, where Pn is a propositional function, we complete two steps, which is here we have to use basis step and inductive step. Okay, basis step is verify P1 is true. Anything is not only 1, but if it begin with 0, we have to prove P0 is true. Then we show that the conditional statement Pk, then Pk plus 1 is true for all positive integer. So there is two things in order to prove whether that's the true mathematical statement, which is basis step and inductive step. Basis step content of P1 and the inductive step content of Pk to Pk plus 1 is also true for all positive integer k. Okay, then okay, this is the metaphora, which is an example why we have to prove one thing true, then all become true. The metaphora is like the domino effect, which is if the first domino falls, then all domino will be false too. So all the domino will fall. Okay, that's the metaphora. Okay, this is the example. Okay, if we have the statement like this, 1 plus 2 plus dot 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 plus n Remember dot 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 meaning that this statement will continuous until n, and it's equal to n plus 1 divided by 2. Okay, now show that if n is a positive integer, so when we read this statement, we know that n is a positive integer, meaning that n will begin with 1, 2, 3, then toward the positive, increasing by using the positive integer. So how can we prove this statement is true? By using the mathematical induction just now, we know that first we have to prove by using the basis step, which is uh, the basis step. The basis step, which is P1 is true. So we know that n is positive integer. The smallest integer in the positive integer will be 1. So P1 is true because 1 here, P1 is true. 1 is equal to 1 plus is equal to, we know that the smallest one, n is equal to 1, right? So when we replace this by using n is equal to 1, we can get 1, 1 plus 1 divided by 2, which is equal to 2 divided by 2, right? And it is equal to 1. So we know that from the left hand side here is equal to right hand side here, 1. Okay, so for the basis step, done. Which is, it is a true statement. Okay, next. For the inductive step, for pk plus 1, first we have to change. Here we have 1 plus 2 plus dot 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 plus n, right? So now we change n into k. So here we get 1 plus 2 plus dot 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 plus k is equal to k plus 1 divided by 2. Under this assumption, it must be shown that pk plus 1 is also true. Okay, now after we have k here, we have to prove k plus 1 is also true. How can we do this? Okay, so after we get k, just add k plus 1, meaning that 1 plus, just now it only have until k, right? So here we add k plus 1. Okay, if we add k plus 1 here, we have to add also here, which is every time we see k, we put k plus 1. And k here also we put k plus 1. And then plus 1, just rewrite it again, divided by 2. Okay, now from this sentence, we know that k plus 1 here, it become k plus 1. And k plus 1 here, it become k plus 2. So k plus 1 times k plus 2 divided by 2. Okay, we get k plus 1, k plus 2 divided by 2 is also true. When we add k plus 1 to both sides of the equation in pk, we obtain, okay, here 1 plus 2 plus dot 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 plus k plus 1. Okay, so here if we add k plus 1 here, we know that here you add k plus 1, right? So from the original one, just add k plus 1 beside it. Then rearrange this equation until you get, okay, rearrange this equation. So here the denominator is 2, right? So we have to put the denominator 2, then here we have to times 2. Okay, ini macam selesaikan pecahan lah. So k plus 1 times 2, k plus 1 divided by 2. So we kembangkan dia. So kita dapat yang akhirnya akan dapat yang ni. Dan yang 2 ni is equal, so it proves that it is true for pk plus 1 for under the assumption that pk is true. This complete the inductive step. Actually, this is the one way how to show the inductive step. Okay. Okay, the other way how to show the inductive step is by using this method, which is from the question just now. 1 plus 2 plus n, then we replace it by k, then under this assumption, okay, here, okay, we want to prove k plus 1, pk plus 1, okay, here, pk plus 1, so just add, this is the original one, right? Okay, just add plus k plus 1, then after we add k plus 1 here, add every time you see the k, every time you see k, just add k plus 1, and here is another k plus 1, and this is k plus 1, then plus 1, just rewrite it again, divided by 2. So the second one is, we know that this is the original one, right? Okay, 1 plus 2 plus dot 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 plus k, just take it, replace it from here, take all this, which is 1 plus 2 plus dot 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 plus k is equal to this, right? Just replace this with 1 plus 2 plus dot 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 plus k with this. Okay, just put it here, then just rewrite k plus 1 beside it. Here we solve this equation, we get k plus 1, we get k plus 1, then k plus 1 plus 1, we get k plus 2, okay, divided by 2. So here we have to rearrange this equation from the left hand side must be equal to the right hand side. Okay, so k plus 1 divided by 2 plus k plus 1. Okay, just make the denominator become same, which is 2. Okay, so k plus 1, and this will become 2k plus 1. Okay, you know how to make from this to this, right? Okay, so expand the equation, then we can simplify it, become k plus 1 plus times k plus 2 divided by 2. So from the left hand side, it is equal to the right hand side. So it's true for the inductive step also. Okay, so it's your choice whether you want to prove it by using this way, or you think that this way is more easier, so you can choose either one. Okay, so next, example 2, which is show that n is a positive integer, then 1 plus 3 plus 5 plus 2n minus 1 is equal to n power of 2. Okay, so from here, first we have to we have read carefully, which is n is a positive integer. When it's called n is a positive integer, meaning that the smallest n will be 1. Okay, when the smallest n will be 1, so here 1 is equal to 1 power of 2 will become 1. So the basis step is true. Okay, done with the basis step. So we move to the inductive step now. Okay, for the inductive step, just now the equation is in n statement, right? Which is involve n. So for the inductive step, just replace n with k, which is 1 plus 3 plus 5 dot 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 plus 2. And just now, just replace it with k, and it is equal to k square. Okay, under this assumption, so now we have to prove that pk plus 1 is also true. So this is the step, which is the inductive step, which is p k and become p. Susahnya nak tulis. pk plus 1. Okay, this is the inductive step. Okay, so now in inductive step, just now we just replace n with k, right? So after that, remember, we have to put k plus 1 beside the original one, which is 1 plus 3 plus 5 dot 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 2k minus 1 is the original one, right? So just plus it with, okay, every time you show you see k, just replace with k plus 1. Okay, now this equation will become 2 times k plus 1 minus 1. Okay, we don't change anything, just put the k, the original k become k plus 1. Okay, now the right hand side, k power of 2 become, every time you see k, please put k plus 1. Okay, this is k, right? So here become k plus 1 power of 2. Okay, so the original one just now, from this equation, right? From this, okay, this equation 1 plus 3 plus 5 to k minus 1, okay, it is equal to k square. So replace all this sentence with k square. Okay, now after you simplify this, you get 2k plus 1. Because of 2 times k become 2k, 2 times 1 become 2, 2 minus 1 become 1. So 2k plus 1. Okay, so here replace this statement with k square, then we get k 2k plus 1. Okay, now we have to prove left hand side is equal to the right hand side. Okay, now after expand this equation, we get k square plus 2k plus 1 is equal to k square plus 2k plus 1. So for the inductive step here, is also true because the left hand side is equal to the right hand side. This is by using the second method just now. Second method. Remember, we have two way to solve inductive step, which is this is by using the second way. Okay. Next is recursive function, recursive definition. Okay, this I will record in the second part. Finish with the first part which is mathematical induction. Okay, what the important thing you have to know about mathematical induction is, first is basis step, which is P1 must be true. Then the second step is P K become P K plus 1 is also true. This is what we call basis step, and this is what we call the inductive step. Okay, for the extra example from this mathematical induction, I'll give you one example here. Please read the question, which is, it said that use the principle of mathematical induction to prove 1 plus 3 plus 9 plus 27 plus dot 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 plus 3 power of n is equal to 3 power of n plus 1 minus 1 divided by 2. For all n is greater or equal to 0. Okay, from here we know that the smallest number it will be 0. It won't be 1 anymore, like previous example. Okay, now for the basis, sorry, susah nak tulis, buruk tulisan. Basis step. Okay, for the basis step here, we not begin with 1 anymore because we know that the smallest one will be 0. Okay, now we have to prove 1 is equal to 1 also. So for the basis step here, we have 1, right? We have 1. 1 is equal to, okay, and here is not 1 because of the smallest one here will be 0, right? Okay, so now we have to replace it with 3 power of 0 plus 1 minus 1 divided by 2, and it become 3. 0 plus 1 will become 1, right? So 3 power of 1, it become 3. 3 minus 1 divided by 2, and it is equal to 2 divided by 2, and it is equal to 1. So from the left hand side is equal to right hand side. So the basis step is true. So done the basis step. For the inductive step, which is P K to P K plus 1. Okay, for here, we know that just replace n with k, so it become 1 plus 3 plus 9 plus, I hope that you will understand my handwriting here, 27 plus dot 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 plus 3 power of k is equal to 3 power of k plus 1 divided by 1, minus 1 divided by 2. So now is pk plus 1. When pk plus 1, pk plus 1 here. Okay, so just replace 1 plus 3 plus 9 plus 27 plus dot 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 plus 3k plus, okay, after the original one we have to put 3k plus 1 is equal to, okay, now every time you see k, just add 3. Okay, here is k plus 1 plus 1. Okay, here we replace k with k plus 1, and 1 here is the original one, minus 1 divided by 2. So now we have to prove the left hand side is equal to the right hand side. Okay. So now we get here, this is the original one, right? So replace it with 3, the original one, k plus 1 divided by 1, minus 1 divided by 2 plus 3k plus 1 is equal to 3. Okay, just simplify this equation. It become k plus 2, right? Plus 2, k plus 2 divided by 1. Okay, now this is the challenge, which is we have to prove the left hand side is equal to the right hand side. So our challenge is to prove this, to make it simplifies and same like this. Okay, now I have to uh okay, how to use this eraser. Okay, okay, wait, okay, yes. Okay, just just now we know that 3k plus 1 minus 1 divided by 2 plus 3k plus 1, it is equal to 3k plus 2 divided by 1 minus, okay, okay, minus, divided by 2. Minus 1 divided by 2. Okay, so now we have to simplify this. How to simplify this? Okay, from here we know that, okay, here is done. So now our task is to simplify this to become this in the circle here. Okay, so now samakan dia punya pecahan kat bawah tu. Jadi 3k campur 1, 3k campur 1 tolak 1. Bila kita samakan pembawah dia 2, jadi yang atas ni akan jadi tambah 2. Yang atas ni akan jadi 3k tambah 1. Okey, just darabkan 2 sebab kita nak bagi pecahan ni semua pembawah dia sama juga dengan 2. Okey, so now daripada sini, ini akan jadi apa? Ini akan jadi, macam mana kita nak selesaikannya? Okey, so kita boleh rearrange this equation become 3k tambah 1 tolak tolak 1. Okey, okey. So sekarang kita tak tolak 1 ni kita letak dekat belakang. Okey, jadi tolak 1 ni padam dia. Okey. Yang ni tambah 2 tambah, okey, 2 okey, tambah 2 kuasa 2 kali 3k tambah 1 tutup kurungan tolak 1 bahagi 3. Okey, so sekarang ni saya nak buat apa? Yang ni kita boleh faktorkan keluar, which is kita faktorkan keluar 3K tambah 1. Jadi yang dalam dia tinggal apa? Ni 3K tambah 1, dua-dua bahagian ada kan? Okey, jadi yang dalam dia tinggal 1 tambah 2. Okey, tolak 1 bahagi 2. Okey, so yang ni dia jadi apa? Yang ni ialah 3K tambah 1 darab. Ni kan? Ni darab kan? 1 tambah 2 akan jadi 3 tolak 1 bahagi 2. Okey, so daripada sini kita tahu bahawa 3 ni ialah 3 kuasa 1. Okey, bila dia 3 kuasa 1, dia ialah apa? Dia ialah 3K tambah 1. Yang ni kita guna yang macam exponential tu. Kalau dia darab, bawah basis dia sama, so dia akan tambah 1 tolak 1 bahagi 2. Dan dia ialah 3K tambah 2. 1 tambah 1 kan akan jadi 2. So tambah 1 ni, sorry sebab space tak cukup. Okey. Okey, ni akan jadi, tadi 1 tambah 1 kan, ni akan jadi 3 tambah 2 tolak 1. So sekarang kita nampak tak yang ni sama dah. Sorry. Sama dengan yang ni. Okey, so bagi yang tak faham, kenapa yang ni saya boleh faktorkan keluar jadi yang tu? Sebab, okey, bagi yang tak faham, yang ni 3K tambah 1 bila saya faktorkan keluar, ni sama juga konsepnya macam kita ada X tambah 2X. Maksudnya kat sini ada X, kat sini ada X kan? Bila kita keluarkan X, dalam dia tinggal 1 tambah 2. Okey, yang ni saya terangkan. Ni konsep dia sama dengan yang ni. Okey, bila saya faktorkan dia keluar macam ni. Okey, konsep dia. Dan yang ini pula daripada sini, macam mana saya dapat 3 ni? Daripada sini, macam mana saya dapat 3 kuasa K tambah 1 darab 3 kuasa 1. Saya dapat 3 kuasa K tambah 2 kan? Ni konsep ni sama juga macam dulu kita belajar exponential. 3 kuasa 1 darab dengan 3 kuasa 2. Bila basis dia sama, dia akan jadi 3 kuasa 1 tambah 2. Jadi kita boleh tambah basis dia sama kan? Kalau kat sini K, maksudnya 3 kuasa K tambah 2. Yang ni saya terangkan pasal ni, macam mana dia jadi benda ni. Okey. Yang latihan ni, saya akan buat saya punya bentuk jawapan. Saya tulis sendiri, nanti saya letak kat Yulen juga. Okey, selamat mencuba. Assalamualaikum warahmatullahi wabarakatuh. Semoga berjaya. InsyaAllah.